So in the next section, what we're going to talk about is how we're going to integrate higher powers of our trig functions, and starting with the higher powers of our sine and our cosine functions. So one thing we're going to have to start with is when we want to look at our powers of our trig functions. And let's suppose that we're dealing with a power of sine and cosine that's odd. This is where you're going to remember your Pythagorean identities. Of sine squared plus cosine squared equals 1. And what happens is you're going to be doing Pythagorean identity substitutions. Remember, cosine squared equals 1 minus sine squared, or sine squared equals 1 minus cosine squared. And the way I kind of also help remember this, if it's an odd power, pull one out. So for example, what that means is, let's take a look at your integral of sine to the third x. What that means is, what I'm going to do is I'm going to rewrite my integral so that I have a sine to the third written as one of my powers just being a sine to the first. So I'm going to rewrite this as a sine squared x times a sine x dx. So that's what I mean when I pull one out, pull one of your factors out. Now this linear part, we're going to do a u sub, and that sine x dx, that's going to want my du to be equal to. Well, I know that if u is equal to cosine, my du would be a negative sine x dx. So then what I can do is I can rewrite this sine squared in terms of cosine by using my Pythagorean identity substitution. So this would be equivalent to your integral of 1 minus cosine squared x times my sine x dx. And again, I want this part to be my du. So then what I'm going to do is I'm going to let u be equal to cosine x. My du is going to be a negative sine x dx. So I'm going to pull a negative out of this integral. So I have a negative, and I can rewrite this as 1 minus u squared times my du. And now I can go ahead and I can integrate this. This is going to give me a negative u minus u to the third over 3 plus c. And then I can bring back in my cosine x. So I have a negative cosine x plus, if I distribute my negative sign, that's going to give me a cosine to the third x over 3 plus c. So again, when you're dealing with a sine or a cosine raised to an odd power, you want to make a single factor of the sine or the cosine and then do a Pythagorean identity substitution, because at this point that should be an even power. So for example, cosine to the fifth. Again, what I'm going to do is I'm going to rewrite this as a cosine to the fourth x times a cosine x dx. And again, this cosine x dx, that's what I want my du to be equal to. So what I know then is I want to let u be equal to a sine, because I know that the derivative of sine is a cosine. So then a cosine to the fourth, I can do a Pythagorean identity substitution in terms of sine. It's just I'm going to have this raised as 1 minus sine squared x, all raised to the second power, times my cosine of x dx. Again, remember, cosine to the fourth x can be written as a cosine squared x squared. So now this is where I can do my u sub. U is going to be equal to sine x. My du is going to be equal to cosine x dx, which is this part of my integral right here. So now I can rewrite in terms of u and du. So this will be equivalent to the quantity 1 minus u squared squared times du. Now we are going to have to FOIL the 1 minus u squared before I can integrate. This means 1 minus 2u squared plus u to the fourth du. And now I'm ready to integrate. That's going to give me a u minus 2u to the third over 3 plus u to the fifth over 5 plus c. And then I can substitute back in my sine. So my final answer would be sine x minus 2 sine to the third x over 3 plus sine to the fifth x over 5 plus c. So if you're dealing with an integral where sine or cosine is raised to an odd power, you pull one factor out and then you can do Pythagorean identity substitutions. Now, if your trig function's already an even power, then this is where you have to remember your cosine, sine, double angle formulas. And remember, the sine, cosine, double angle formulas are actually derived from the sum and difference formulas. Remember, cosine of u plus v is cosine u, cosine v, minus sine u, sine v. And again, this is where the derivation of the cosine double angle formula. Remember, your cosine double angle formula has actually has three variations. The two that we're going to concern ourselves with is cosine of 2x is equal to 1 minus 2 sine squared, or cosine 2x is 2 cosine squared x minus 1. So if you take a look at the cosine of 2x being equal to 1 minus 2 sine squared x, what I'm going to do is I'm going to take this double angle formula and I'm going to solve for sine squared x. So I'm going to subtract 1 and divide by negative 2. So cosine of 2x minus 1 over negative 2 is equal to sine squared x, or sine squared x is equal to 1 minus cosine of 2x all over 2. The idea is we want to break this power of sine squared down to a trig function raised to the first power. So then I can take a look at my other variation of the cosine double angle formula. Cosine of 2x is equal to 2 cosine squared x minus 1. So again, if I solve for cosine squared, I'd add 1 divided by 2. So cosine squared x is equal to 1 plus cosine of 2x all over 2. Notice they're exactly the same, except sine has subtraction sign, and I always remember because sine begins with an s, so does subtraction. So these are the double angle formulas we're going to need to remember when we deal with integrating sine or cosine raised to an even power. So let's take a look at sine squared x dx. So notice sine is raised to an even power. So what I'm going to do is I'm going to do a double angle substitution on sine squared x. So I can rewrite this as a 1 minus cosine of 2x all over 2 dx. I can pull out a 1/2. So I have 1 minus cosine of 2x dx. So again, when I integrate 1, that's just going to give me 1/2 x. Minus, now I have to integrate 1/2 times the cosine of 2x dx. So I'm going to have to do a u sub here. So again, u is going to be equal to 2x, du would be equal to 2 dx. So the constant I'm going to have on the front then, that's going to give me a minus 1/4. So I have my 1/2 x minus 1/4, and I know when I integrate cosine, that's just going to give me a sine, so that'll give me a sine of 2x plus c. Again, the idea is when you do that double angle substitution, you want to get it down so that your trig function is raised to the first power for sine or cosine so you can integrate. So now let's take a look at when you have cosine to the 4th x. So I'm just going to get a clean sheet of paper here. So cosine to the 4th x dx. So what I'm going to do is I have to rewrite this as a base raised to the 2nd power. So I'm going to rewrite this as a cosine squared x quantity squared dx. So what I'm going to do is I'm going to do a double angle substitution for this cosine squared. So cosine squared I know is going to be my integral of 1 plus cosine of 2x all over 2 raised to the 2nd power dx. So again, the constant I can pull out then, since I'm squaring the numerator and denominator, I'm going to pull out a 1/4. So now what I'm going to do is I'm going to have to FOIL. So that's going to give me a 1/4 times my integral of 1 plus 2 cosine of 2x plus cosine squared of 2x dx. So I can integrate this, I can integrate this term. I'm going to have to do another double angle substitution when I get down to that part. So when I integrate 1, that's going to give me a 1/4 x. Plus, I am going to have to do a u sub right here. So when I integrate, I'm going to integrate, again, I have 1/4 times 2 cosine of 2x plus 1/4 times my integral of cosine squared of 2x dx. So I can pull out this 2, so that's going to give me still, I still that 1/4 x, that's going to give me a 1/2 times my integral of cosine of 2x. So again, I am going to have to do a u sub, so u is equal to 2x, my du is 2 dx. So this is going to give me another 1/4 right here. So I have 1/4 x plus 1/4, and I know when I integrate cosine of 2x, that's just going to be a sine of 2x. So I have 1/4 x plus 1/4 sine 2x. So now let's talk about how I'm going to integrate this 1/4 cosine integral of cosine squared 2x. So I'm going to have to do a double angle substitution. Now, this isn't just, this is cosine of squared of 2x. So cosine squared of 2x, because it's not just an x, I'm going to actually have to rewrite this as a 1 plus the cosine. Now again, it's 2 times 2x, which will give me a 4x, all over 2 dx. So I can pull that constant out, so that's going to give me a 1/8 times my integral of 1 plus cosine of 4x dx. So now when I start the integration of this part right here, remember I still have that 1/4 x plus 1/4 sine of 2x. Plus, when I integrate 1, that's just going to give me an x, so that's 1/8 x. Plus, now I have to integrate 1/8 times my integral of cosine of 4x dx. Again, I'm going to have to do a u sub, so u is equal to 4x. My du is equal to 4 dx. I'm dividing by 4, so that's going to give me 1 over 32. And again, I know when I integrate cosine, that's going to give me a sine of 4x plus c. So then my final answer would be a 1/4 x plus 1/4 sine of 2x plus 1/8 x plus. And that's how you integrate the even powers of sine and cosine. If it was a multiple choice question, you could combine the 1/4 x plus 1/8 x to give me a 3/8 x plus 1/4 sine of 2x plus 1 over 32 sine of 4x plus c. Again, if it's a free response question, you're okay to leave it like this. But again, multiple choice, they would simplify it down, combining those like terms.